Hello student, the question says, in the given circuit, the diode D1 and D2 have the forward resistance of 25 ohm and infinite backward resistance. When they are connected to the source as shown, the current passing through the 175 ohm resistor is. So let us take this diagram and we need to find what's the current flowing through this 175 ohm resistor. So let us draw the current flow diagram. And remember, the goal of the current is to go from positive plate and reach the negative plate. You might wonder, why can't it directly jump from positive plate to negative plate? It cannot go through that. It has to go through a wire only. So let us assume this is my current that is traveling from positive plate. As it is traveling, it wants to go to the negative plate. So it went through the resistor. And here it has two paths. So since it has two paths, let us assume a part of the current is going this way and another part is going this way. So when a part of the current wants to go this way, as you can see, this is not allowing the current to flow. This is basically a reverse bias connection. It's like a traffic police telling us to not go in this direction. It's like a stop sign. So the current cannot go in this way. So the entire current, this route is reverse bias. So no current can go through this route. The entire current has to go through this route only. So the current has only one route, and this is forward bias. It's like a traffic police is telling us to go. You might wonder, why can't it go and stop here? Like it's not like that. You have to see first, did we meet the arrow or did we meet the plate? Here, if we go in this direction, you are meeting this stop sign first. So this is a reverse bias, or we can say we are meeting the n side. So it's a reverse bias. Here we are you meeting the arrow side. That means it's forward bias. So the current can happily flow. And remember, some people think, why can't the current again go in this way? The goal of the current is to go from positive plate to negative plate. So it will never go in this way. It has to go in this direction. Again, I will repeat. If I draw the current flow diagram, it will start from the positive plate. It will come here. It came to a junction where two routes are available. In this route, we have a stop sign, or we can say it is reverse bias. So no current will be allowed. The current has to go through this route only. And eventually it will make it into the negative plate. So I'll draw the current flow diagram. No current will flow through this. So this is the current flow diagram. And once we understood the current flow diagram, so we can directly remove this, since this is in reverse bias. And it is given in the question that this resistance in forward bias, this diode in forward bias offer 25 ohm forward bias resistance. So in place of this, we can write a 25 ohm one. We can redraw this entire circuit. We can completely remove this because no current is flowing through this. And in place of this diode, I can draw a resistance of 25 ohm. Now the current is flowing this way. Once we get this, we'll use loop law. So if I use Kirchhoff's loop equation, we'll get 175i. I'll start from here, 175i plus 25i. And we met the negative plate first, so minus 10. Here, for one battery, we have to take only once. We cannot write minus 10 and again plus 10. So we met the negative plate first. I'm traveling in this way in the direction of current. I hope you already know Kirchhoff's loop equation. So minus 10 plus 50i equals to 0. So we get 250i equals to 10. I equals to 10 by 250. So we can write it. Let us make denominator into or 1 by 25. 1 by 25, I'll write multiply 4 in the numerator and 4 in the denominator to make calculation easy. So we get 0.04 ampere. 0.04 ampere means simply it's our option 4. Hope you understood how I have solved. You have to identify which is in which the current will flow and in which the current does not flow, and solve it like a regular current electricity problem. Thank you.